Hello learners, I am Dr. Subodh Kesharwani, working with Indira Gandhi National Open University in School of Management Studies. The topic which I am going to talk today is one-tailed test and two-tailed test. You know that this is part of our course called MCO3, Research Methodology in Statistical Analysis, and we are here with the testing block, which is the fourth block of this particular course, and much more focused on testing of hypothesis. So we have already a lot of sessions talking more about the test, starting from hypothesis test or the one-tailed or two-tailed test or type 1 error, type 2 error. But here we are just focusing on one-tailed test and two-tailed test, and in our forthcoming sessions we are going to talk more about the Z-test, F-test or the chi-square test, which are important ingredient as far as the testing is concerned. So anyway, in statistical significance testing, a one-tailed test and two-tailed test are alternative ways of computing the statistical significance of a parameter inferred from a data set in terms of test statistics. A two-tailed test is appropriate if the estimated value is greater or less than a certain range of values. For example, whether a test taker may score above or below a specific range of scores. This method is used for null hypothesis testing, and if the estimated value exists in the critical areas, the alternative hypothesis is accepted over the null hypothesis. So in our preceding sessions we have very distinguishedly talk about what is the difference between hypothesis and then null hypothesis and alternate hypothesis, and this is where the application of hypothesis is using in a great manner. So a one-tailed test is appropriate if the estimated value may depart from the reference value in only one direction, left or right, but not both. An example can be whether a machine produces more than 1% defective products. In this situation, if the estimated value exists in one of the one-sided critical areas, depending on the direction of interest greater than or less than, the alternative hypothesis is accepted over the null hypothesis. So alternatively, if we go into the depth of this one-sided and two-sided test, the terminology tail is used because the extreme portion of distributions where observation lead to rejection of the null hypothesis are small and often tail off towards zero, as in the normal distribution colored in yellow or bell curve pictured on the right and colored in green. So this is what exactly if you see this particular image, I think this image is quite explanatory, because you will find out that there are two images are there which is in yellow color. So this is considered as a left tail and this is considered as a right tail. So on the other hand, if you see this particular image, you will find out that it is giving us the p-value and it is a right tail. Because why we are talking about the tail? Because we have seen that this terminology tail is because the extreme portion of the distribution where observation lead to rejection of the null hypothesis are small and often tail off. So that is the reason. So p-value is a shaded green area, is the probability of an observe for more extreme results arising by chance. So what is hypothesis? A hypothesis is an assumption about the population parameter. A parameter is a population mean or proportion. The parameter must be identified before analysis. So assume that CGPA of this class is 4.5. So different hypotheses tests are there, and we have talked some about some tests like the type error and type 2 test, the testing of hypothesis, and in the coming sessions we are going to much focus on t-test, which is also known as student t-test, or the z-test or f-test or chi-square test. So these some of the tests which are considered as a parametric and which assumes the data subscribe to a distribution, and some of the tests are non-parametric, makes no assumption about the underlying distribution of the data. And you will find out that as far as the parametric tests are concerned, there are certain tests which comes under the ambit of the parametric, like t-sample test or the sample t-test or pair t-test, test for equal variances, proportion test, chi-square goodness of fit, and chi-square test for independence. So these are the tests which are there and compares on sample average to historical average on target if we talk about, whereas non-parametric test much focus on one sample median to a historical median or target. So we will talk more about all these the tests in a coming sessions or in forthcoming sessions with certain examples. But here we are more emphasizing on one-tail and two-tail test. So if we are going to distinguish between one-tail and two-tail test, which was popularized by Ronald Fisher in the influential book Statistical Methods for Research Workers, where he applied it specially to the normal distribution, which is a symmetric distribution with two equal tails. The normal distribution is a common measure of location rather than goodness of fit and has two tails corresponding to the estimate of location being above or below the theoretical location. For example, sample mean compared with theoretical mean. So in the case of a symmetric distribution such as the normal distribution, the one-tailed p-value is exactly half the two-tailed p-value. So if you are going to differentiate one tail and two tail, one tail tests are used for a symmetric distribution that have a single tail such as chi-square distribution, which are common in measuring goodness of fit, or for one side of a distribution that has two tails such as the normal distribution, which is common in estimating location. This corresponds to a specific direction. So two-tailed tests are only applicable when there are two tails such as in the normal distribution and correspond to considering either direction significant. If flipping a coin, testing whether it is biased towards heads is a one-tailed test, and getting a data of all heads would be seen as highly significant, while getting data of all tails would not be significant at all, p equals to 1. So by contrast, testing whether it is biased in either direction in a two-tailed test and either all heads or all tails would be seen as highly significant data. Now in medical testing, while one is generally interested in whether treatment results in outcome that are better than chance, thus suggesting a one-tailed test, a worse outcome is also interesting for the scientific field. Therefore, one should use a two-tailed test that corresponds instead to testing whether the treatment results in outcomes that are different from chance, either better or worse. Now determine whether to use a one-tail or two-tail statistical test. A two-tailed test will test both if the mean is significantly greater than x and if the mean significantly less than x. The mean is considered significantly different from x if the test statistics is in the top 2.5% or bottom 2.5% of its probability distribution, resulting in a p-value less than 0.05. Hypothesis testing. Two-tailed test. A hypothesis test in which alpha area of interest falls in both tails of a z or t distribution, which we are going to cover in our forthcoming session, and we will see how important the two-tailed test is when we are going to evaluate with the help of these tests, either z test or t distribution. And if we take example of a null hypothesis where m is equal to 4, and alternate hypothesis where m is unequal to 4. And if we take an example of one-tailed test, a hypothesis test in which the alpha area of interest falls in just one tail of a z or t distribution, and null hypothesis is mu is greater than or equal to 4, and alternate hypothesis which is quoted by H1 where mu is less than 4. We have another example where alternate hypothesis is greater than 4, and as far as null hypothesis is equal to or less than 4. So this is called a directional hypothesis test. Now research in null hypothesis. One tail specifies the hypothesized direction, and research hypothesis is quoted by if alternate hypothesis mu2 is greater than mu1 or mu2 minus mu1 is greater than 0. On the other hand, if you talk about the null hypothesis, mu2 equals to mu1 or mu2 minus mu1 equals to 0. Now on the other hand, two-tailed direction is not specified, more common, and research hypotheses are alternate hypothesis mu2 unequals to mu1 or mu2 minus mu1 unequals to 0, whereas null hypothesis mu2 equals to mu1 or mu2 minus mu1 equals to 0. Nature of test, there are three types of hypothesis tests: left-tailed test, right-tailed test, or two-tailed test. If you talk about the type of test depends on the region of sampling distribution that favors a rejection of a null hypothesis. This region is indicated by the alternative hypothesis. The basics of one-tailed test, if we go more into the backdrop, hypothesis testing is run to determine whether a claim is true or not given a population parameter. A test that is conducted to show whether the mean of the sample is significantly greater than and significantly less than the mean of population is considered as a two-tailed test. So one-tailed hypothesis test, if we talk about a hypothesis test in which the alternative is stated in such a way that the probability of making a type 1 error is entirely in one tail of a sampling distribution. And if you talk about right-tailed test, a one-tailed test in which the sampling outcome is hypothesized to be at the right tail of the sampling distribution. And if you talk about the left-tailed test, a one-tailed test in which the sample outcome is hypothesized to be at the left tail of the sampling distribution. So this is basically the one-tailed test. One-tailed test, if we are talking about, either it could be the left tail or right tail, and if there could be both, that is left tail and right tail, we will say it's a two-tailed test. So right-tailed test, if we talk about the alternative hypothesis which is mentioned by HA contains greater than inequality symbol, and mu is equal to k as far as null hypothesis is concerned. As far as alternate hypothesis is concerned, mu is greater than k. And if you see the image, you will find out that test statistic is going to be quoted by this blue area, and P is the area to the right of the test statistic, which is at the right bottom of the bell-shaped curve. So the alternate hypothesis, if we are quoted by HA, contains the less than inequality symbol, and mu is equal to k and mu is less than k. And if you see the test statistic, it would be at the left side, and P is the area to the left of the test statistics, and you will find out that it is having a left tail curve. So what is two-tailed t-test? In statistics, a two-tailed test is a method in which the critical area of distribution is two-sided and tests whether a sample is greater than or less than a certain range of values. It is used in null hypothesis testing and testing for statistical significance. So two-tailed test, if we go more into depth of that, the alternative hypothesis contains not equal inequality symbol, and each tail has a area of half p. So if we talk about the null hypothesis, mu is equal to k. If we talk about alternate hypothesis, mu is unequal to k. So if you see this image, I think P is twice the area to the left of the negative test statistics and would depict at both the sides. It could be at the left side. If you see the image, it could be at the right side. So test statistic is there at the both side, and left side could be called the left tail and right side could be called the right tail, and this is called the two tail because you will find a flavor of left and right both. So P is twice the area of right of the positive test statistics. So how is P value difference between one tail and two tail test? So the one tail P value is half the two tail P value. The two tail P value is twice the one tail P value. Assuming you correctly predicted the direction of the difference, this rule works perfectly for almost all statistical tests. Now the question is, can a one sample t-test be two-tailed? So there are two kinds of hypotheses for a one sample t-test. The null hypothesis and the alternate hypothesis, which we have already covered in the chapter called hypothesis, and in this particular session or in the past session when we are much focusing on the test, we are talking more about this. So if the goal is to measure any difference regardless of direction, a two-tailed hypothesis is used. So when to use a one-tailed and two-tailed test? This is because a two-tailed test uses both the positive and negative tails of the distribution. In other words, it tests for the possibility of positive or negative differences. A one-tailed test is appropriate if you only want to determine if there is a difference between groups in a specific direction. So how do you know if it's a one-tailed or two-tailed test? A two-tailed test will test both if the mean is significantly greater than x and if the mean significantly less than x. The mean is considered significantly different from x if the test statistics is in the top 2.5% or bottom 2.5% of its probability distribution, resulting in a p-value less than 0.05. So we can take some good examples. I think the examples can defend the thoughts in a more elaborative manner. And the example which we have taken, like identifying the nature of a test, for each claim state HO as a null hypothesis and HA as a alternative hypothesis. Then determine whether the hypothesis test is left-tailed, right-tailed or two-tailed test. Sketch a normal sampling distribution and shade the area for the p-value. A university publicizes that the proportion of a student who graduate in 4 years is 82%. So if we talk about null hypothesis, is quoted by p equals to 0.82, and if we talk about the alternate hypothesis, p is unequal to 0.82. Now this is two-tailed test because when we have plot this, the half p-value area is there at the bottom of the bell-shaped curve, and this is called the left tail and this is called the right tail. So half p-value area is both the sides. So that is the reason it is called the two-tailed test. And if we take an example, another solution, I think, for identifying the nature of test, for each claim state null hypothesis and alternate hypothesis, then determine whether the hypothesis test is left tail, right tail or two tailed. Sketch a normal sampling distribution and shade the area for the p-value. A water faucet manufacturer announces that the mean flow rate of a certain type of faucet is less than 2.5 gallons per minute and mu is equal to 2.5, and this is called null hypothesis. And if you talk about alternate hypothesis, mu is less than 2.5. So this is called left tail because the p-value area is coming at left side, which is in blue color at the bottom of the tail. Now we can take an example of a right tail test. So alternate hypothesis is there and null hypothesis is there. Then determine whether the hypothesis test is left tail, right tail or two tail. We are going to sketch a normal sampling distribution and shade the area for the p-value, and take example of a company advertised that mean weight of the contents of its 20-ounce size boxes is more than 20 ounces. So mu equals to 20 and mu is greater than 20. So now we can have a p-value area which is at the right side. So that is the reason we are saying it's a right tail test. So hypothesis test means, so a one tail test, if we talk about and if we take alternate hypothesis, mu is less than 4, entire alpha area is on left as opposed to half alpha by 2 on each side, and the critical t value changes. So you find out that if we talk about two tail hypothesis test, you will find out that two tail hypothesis test, hypothesis test in which the region of rejection falls equally within both tails of sampling distribution. We have taken an example, and if we take this particular example, which could be quite pragmatic in nature. So the process of conducting a two-tailed hypothesis test is very similar to the one-tailed test, except the critical values are slightly different. Since a two-tailed test, both above and below the claim value, a 0.05 significance level would have to be split between the two extremes, thus looking for a z-score that corresponds to a probability of 0.025. And here what we have observed that we have two-tailed. If you see, the green color is nothing but a left tail and right tail, and 5% of values lie either below the 2.5% percentile or above the 97.5% percentile, corresponding to standard scores of -1.6 and 1.6 respectively for significance at the 0.05 level. The Z scores that correspond to probability of 0.025 are -1.96 and 1.96. So far, two-tailed test, it is significant at a 0.5 level if the Z score is less than or equal to -1.96 or greater than or equal to 1.96. So for a two-tailed test, the 0.01 significance level would mean that Z score need to be correspond to a probability of 0.005, that is 0.01 split in half. The Z scores that correspond to a probability of 0.005 are -2.575 and plus 2.575. So if the Z score is less than or equal to -2.575 or greater than or equal to 2.575, then it is statistically significant at the 0.01 level. So summary of critical values of two-tailed test is 0.05 significance level, Z is less than or equal to -1.96 or Z is greater than or equal to 1.96. On the other hand, if 0.01 significance level is Z is less than or equal to -2.575 or Z is greater than or equal to 2.575. Now, common errors in hypothesis testing. After doing this right tail, left tail test, I think there are certain type 1 errors and type 2 errors which we have usually covered in our preceding session, but it had a linkage with this. So a hypothesis test guides us in the right direction of either supporting or not supporting a claim, but even if a hypothesis test is carried out correctly, two common types of error may affect their conclusion. We have already talked about this in a preceding session, but as I have already told that in statistics, a lot of linkage is there. Whatever we have covered in a preceding session, say hypothesis we have covered in a preceding session as a null hypothesis or alternate hypothesis, but here as far as testing is concerned, we are having a great use of hypothesis. So type 1 and type 2 error which we have covered in a preceding session, now we are going to apply as far as this one tail and two tail test is concerned. So when the null hypothesis is wrongly rejected, this is called type 1 error. And if we consider a drug company that seeks to be sure that it is 500 milligram aspirin tablets really contain 500 milligrams. So if the tablet contain less than 500 milligrams, the consumers are not getting the advertised dose. And if the tablets contain more than 500 milligrams, the consumers are getting more than the advertised dose, which could be potentially dangerous. Suppose that a hypothesis test gave evidence to reject the null hypothesis, thus stating that the drug does not contain 500 milligrams when in reality it does contain 500 milligrams. So this would be an example of type 1 error. It is appearing as though the drug has either more or less aspirin in that it should be, when it in reality it has the correct amount. So the type 2 error, if you are talking about when the null hypothesis should be rejected, but it was not. So considering the drug scenario above, suppose that hypothesis test gave evidence to not reject the null hypothesis. stating that the drug does contain 500 milligrams when in reality it does not contain 500 milligrams. So this would be an example of type 2 error. It is appearing as though the drug has the correct amount of aspirin when in reality it does not. So hypothesis test about means. So t value changes because the alpha area, that is 5%, is all connected in one side of distribution rather than split half and half. So one tail test and two tail test, if you take an example, alpha is equal to 0.5 and you find out this is a one tail and it's a left tail, rather we can say, where if you talk about the two tail, alpha by 2 is 0.025 and alpha by 2 is 0.025, and you find out you have flavor of red in both the sides, either left side and the right side. So this is the example of a difference between the one tail and two tail. So if you look at the table and find out the student t distribution, which we are going to study in our coming sessions in a more elaborative manner under the ambit of t test, you will find out that this how much if we the 95% t value changes when you switch from a two tail to one tail test. So this is the way by which we are going to do that. DF is nothing but a degree of freedom, is the number of values in the final calculation of a statistic that are free to vary, the number of independent ways by which a dynamic system can move without violating any constraints imposed on it. So it is called the number of degrees of freedom. So two tail test, one tail test is there, and degree of freedom is there, and level of significance for the values are there. So you will find out that we are just concentrating on 0.05 and 0.025, and what we have observed that when we, as far as two tail is concerned, the t value is coming 2.086, and if we talk about one tail test, the value of t is coming 1.725. So this is what exactly, so t value changes because the alpha area 5% is all concentrated in one side of the distribution rather than split half and half, and this is the way by which concentrating the alpha area in one tail reduce the critical value t needed to reject null hypothesis. So now test for difference in means, a more useful application, two groups. Whenever you compare two groups, you will observe different means. Is the difference due to the particular sample but population have the same mean, or we can infer the population are different? So this is the way by which we are going to complete this particular session. And as far as one tail or two tail is concerned, it's very important because the application of it is not apply in this t test, z test, but all the tests you have a use of all those things. So by that I am going to wind up my session, and in our coming session we are going to more focus on certain test and apply whatever we have studied in our preceding session. Thank you very much. Thank you, learners.